Okay, these are the big ideals Algebra 1 6.6 notes, and today we're going over geometric sequences. So in a geometric sequence, what's happening is that between any two consecutive terms, they are being multiplied by the same number. So in this case, this geometric sequence, every single number is being multiplied by 5 to get to the next number. Because they're being multiplied by the same number, this number is called the common ratio, and that's how you know they're a geometric sequence. When we had a sequence earlier, we had an arithmetic sequence. And so what the difference was on an arithmetic sequence, it would have been something like 3, 5, 7, 9, on and on. And in this case, each term was changed by the same number, but each was added by 2. And so because they were added by the same number, that's how you know it's arithmetic, versus multiplied by the same number, it's going to be geometric. And so that's kind of the main concept that we're going over today. Okay, so on this first example, they want to know if the sequence is arithmetic, geometric, or neither. So I can tell by looking at this one that more than likely it's probably geometric because the numbers are going up very quickly, and then they're oscillating between positives and negatives and positives and negatives. So since they are switching sign, I feel like it's probably being multiplied by a negative number. So from 1 to negative 4, if you took 1 times negative 4, you would get negative 4. Negative 4 times negative 4 would be positive 16, and 16 times negative 4 would be negative 64. So basically, to explain this, I would just say that it's geometric, and then for the explain your reasoning portion, I would just say that it has a common ratio of negative 4. And how you had a clue that it was negative was because the signs were switching between positives and negatives. Okay, on number 2, looking at this one is not going up drastically fast, and just by looking at it, I know that this is going up 4, just adding. This is plus 4, and 11 plus 4 is 15. So this is going to be an arithmetic sequence. And what we call this, instead of a common ratio in an arithmetic sequence, from the previous chapter we've done, it was called a common difference. And we say it has a common difference of 4. Okay, so now on number 3 here, if we look at this, it's going up very quickly, so if it is something, it's probably geometric, but let's take a look. 2 times 2 gets you to 4, 4 times 2 gets you to 8, and then 8, if I did times 2, I would be at 16. But since it skipped 16, it was times 4. These numbers are not consistently the same. Not every single one is times 2. And so because of that, I can say that it's neither. Now, it's a good idea to go ahead and check arithmetic, but just by looking, I know we're adding 2, we're adding 4, and then we're adding 24, so it's clearly not arithmetic. And so for my explanation, I could just say there is no common difference or ratio. And that would be a perfectly fine explanation. Okay, on number 4. Number 4, same thing. This one's going down. So if we look at this, from 12 to 9, let's see here. It is being subtracted by 3. And from 9 to 7, we're subtracting 2. And from 7 to 5, we're subtracting 2. So I kind of hesitate to say that that'd be arithmetic because it isn't going down the same amount. And geometrically, this would be like multiplying times, what would that be, 3/4, I believe. And so then if you check 9 times 3/4 in a calculator, you'd find that it didn't work for everything. So I would say neither, once again. And for my reason, I would say that there is no common difference or ratio. And by common difference or ratio, I do mean common difference or common ratio, but I feel like that more or less goes without being said. So on number 5, looking at this, once again, it looks like it gets very big very quickly. I know that 6 times 3 is 18, but I'm not sure about 18 times 3, so let's just go ahead and check it. And so we type it in our calculator. 18 times 3 is in fact 54. So let's go ahead and check 54 times 3. And 54 is definitely also 162. So I can say that this is geometric. And I would say that it has a common ratio of 3. So then on number 6, if I look at this one's going up by, let's see here, 8, and then up by another 8, and then up by another 8. So every single time we're adding 8, so because we're adding the same number over and over, I would say that it's arithmetic. And I'd say that there is a common difference of 8. And honestly, these just get better and easier as you practice them and you start to see the patterns and recognize them. Over several examples, you will start to get where you're recognizing them quicker and kind of have more of an instinct of which way to start looking first. Okay, so moving on to number 7 through 9, it says write the next 3 terms of the geometric sequence. So first, you know it's geometric, so let's go ahead and identify what it's being multiplied by. So in this one, I know that it's being multiplied by 3 every single time. That's clear that that's what's happening. So if I just go in my calculator and do 189 times 3, the next term is 567, and then do that times 3, and it is 1,701. And then do that one times 3, and it's going to be 5,103. Okay, so number 8. On this one, I just need to find out what's happening. So what I'm going to do to find the ratio is I'm going to take 288, the number on the right, divided by the number on the left. So I'm going to do 288 divided by 576. So I find out that it is being multiplied times a half. So half of 576 is 288. Half of 288 is 144, and half of 144 is 72. So I'm going to take 72 times half. So when I do that, I'm going to get 36. 36 times half is 18, and 18 times half is 9. Okay, so on number 9, do you see how it's going positive and then negative and positive and negative? That's called oscillating between signs, meaning it's just switching signs every single number. So that's my main clue, that this has a common difference that is a negative number because that's what's allowing us to switch the signs. So from 5 to negative 10, it multiplies times negative 2, and then negative 10 times negative 2 is positive 20, and so on. So if I take negative 40 times negative 2, I get 80. If I take 80 times negative 2, I get negative 160. And negative 160 times negative 2, I'm going to get positive 320. So these are the next 3 terms in my sequence. Okay, still in your student journal on page 196, this one says to write the next 3 terms of the geometric sequence and then go ahead and graph the sequence. So once again, this is one where I want to find out what's happening. So this, I know it's multiplying times a half every single time. So my next terms, if I take 3 halves, and you could just do this in the calculator if you don't know it in your head. So I could take 3 halves times 1 half, and I would find out that it's the same as 3/4. Then I could take 3/4 times 1 half, and I find out that it's the same as 3/8, and then 3/16. So now it wants me to graph these. So this is actually very easy to do. Think of them as pairs. Basically, if you kind of glance ahead at the next page of your student journal, you're going to see graphs already laid out. So if you look at these, the numbers on the bottom are it's the number of terms. And the numbers going on the y-axis are going to be like how high they go. So if you think about this as being the point 112 because it's the first term, 2,6 because it's the second term, 3,3 because it's the third term, 4 and then 3 halves because that's the first term, and so on. You'd have 5, and then you'd have 3/4, 6, 3/8. Sorry, that should have been a comma. And so on. The x value is really just your number of terms. We're saying this 7th term is 3/16. So now we know that it needs to go up to 12, and it's going to be a little hard to fit some of these decimals in. But let's just go ahead and label up this axis. So right here, I'm going to have my x-axis. I'm going to label it in for the number of terms, and I'm just going to mark down to show that we are going by ones. You really wouldn't have to mark every single one, but I'm just going to for the convenience of doing the example. Okay, so up here, we need to go to 12. So let's just take a look. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 boxes, it's not going to quite fit. On this one, because the numbers do fall so drastically, I'm honestly going to go ahead and just extend it up to 12 because it is right there. So I'm just going to mark that we're going by ones because it's convenient. So now let's graph the point 112. So that's going to be up here. And then the point 26, 1, 2, 3, 4, 5, 6. And the point 33. Now, do not connect these points, okay? Don't try to draw on a curve. That's not at all what I want you to do. There is 3 halves is 1.5. 3/4 is about right there. 3/8 is just below a half. And then that's getting pretty small to graph. So we'll just leave it with dots right there. Okay, so on this one also, still writing the next three terms of the geometric sequence. So if we take a look at this, these every single time are being multiplied times 4. So 192 times 4 is going to be 768. And then 768 times 4 is going to be 3072. And then multiply that times 4, and we're going to end up with 12,288. So those are our various terms. So let's go ahead. Now this one I definitely cannot go by ones on the y-axis, but I absolutely can still go by ones on the x-axis. So this is still the number of terms, which is 1, 2, 3, 4, 5, 6, 7, and so on. Okay, so now up here, we need to go all the way up to 12,000, which is going to be pretty hard to do. So honestly, I might not even graph that one on here just because it is going to skew my graph so far, and I might choose just to go by 500s. It's still going to make my graph look very off, so if you wanted to just not do these two in this case because I didn't provide you with large enough graphs, I'd be okay if you went by 100s, 2, 3, 4, 5, 6, 700. And so that would mean that term 1 is at 3, and that's basically extremely close to this line. You're not going to see a lot of difference between 1, 2, 3 is 48, which is about halfway to 100, not quite though. 4 is 192, which is almost to 200. And then 5 is 768, so there's 700, so it's past the halfway mark. And so that's what our geometric sequence looks like. And we just don't have room to get all the way up to 3,000. Otherwise, these points would all look very close together, and it would not make a nice curve. Okay, so on this one goes from 0.008 to 0.04, then to 0.2, and then to 1. And so I can tell by looking that this is multiplying times 5, and that's the common difference. So 1 times 5 is 5, 5 times 5 is 25, and 25 times 5 is 125. Now, if you're not sure how to tell, take one of the right numbers, divide it by the number directly to its left, and if we just type this in just to see, 0.04 divided by 0.008, and we're going to end up with 5. And so that's one way you can check it, is take one of the numbers on the right, divide it by the number on its left, and you'll find the common difference, the common ratio, and that's if we already know that it's geometric. Not if we're trying to prove it, but if we already know so. So go ahead and let's set up this graph. So once again, our number of terms is pretty easy, because we know that there's just going, in this case, from 1 to 7. And so our number of terms will always go by 1s. We usually will not skip or do anything crazy like that. Now, a little harder to figure out what to do on the y-axis. So on the y-axis, we're going to figure out we need to go from 0.008, which is very close to 0, all the way to 125. So personally here, once again, it's maybe not our best way to do it, but if I don't graph 125, I have a lot more room to spread out these points and make it a lot more reasonable. So if I do this, then I feel like I could, I'd say fairly safely, maybe even just skip and go up to 5. If I did that, I could go by halves. So I could say that this was 0.5, this is 1, this is 1.5, this is 2, 2.5, 3, 3.5, 4, 4.5, and 5. So now if I graph this, 1 is at 0.008. That is extremely close to 0. 2 is at 0.04. Once again, not doing much better there. The third one, so I have term 1, term 2, term 3, term 4. So the third one is at 0.2, so that's going to be more in here, not quite halfway to 0.5. 4 is at 1, which is right there, and 5 is all the way up at 5. So I went ahead and kind of forgoed writing the last 3 on my graph because it would have made my scale such that it would have been crazy. If you think about this, if this amount's 5 times higher off my screen is going to be 25, and so its growth is crazy on this one. Okay, so the next thing we're looking at is right here. So it's the equation for a geometric sequence. So how you write a geometric sequence, you're always going to start with a sub n. Now this a sub 1 right here, this is the first term. And so whatever your first term is, you're going to rewrite it right there. Now, the r is your common ratio, and so you're going to put r right in there, and you're going to have n minus 1 as your exponent every single time. And that's how you find the nth term. So if you want the 7th term, you just plug a 7 into there. If you want the 120th term, you plug 120 in for n. So let's go ahead and just write it right here. It's a sub, and did you notice that it said a sub n right here? That means the answer to the nth term. And so a sub n equals the first term times r to the n minus 1 power. So basically what we need here is we have the first term. Now let's find the r. So if we look at this, let's go ahead and take, remember I said the term on the right divided by the term on the left. If you can't just obviously see what it is, this is a great way to find out. So it's being multiplied times 1/3 every single time. And you can go through and check this. So there's your first term. Your ratio is 1/3. So our equation would be a sub n equals, now write your first term here, 6,561. Put your common ratio right there, 1/3, to the n minus 1. And that is your answer to this problem. Now if you look at this, this is being multiplied times -3. And so your ratio is -3. 8 is your first term. So we do a sub n equals 8, and then -3 in parentheses, n minus 1 is the exponent. And so if we look at this, I'd say this is times 5. 15 times 5 gets you 75. So we know that this is our first term. And our common ratio is 5. That's what it's being multiplied by. So we have a sub n equals your first term. Your common ratio goes right in there. And the power is n minus 1. Alright, now in all of these, it wants us to go ahead and wants us to find a6. So that means the 6th term. So what we do on all of these is we just go ahead and we take the formula and we plug in 6. So I'm just going to type in 6,561 times 1/3. Now please make sure to use a fraction there. 0.3 is not the same as 1/3, so don't go and just type that. And I'm going to go ahead and put to the 5th power because I know up here 6 minus 1 is 5. So my answer, a sub 6 equals 27. That means the 6th term in the sequence is 27. Now if I went ahead and found a sub 6 on this, 8 times -3 to the 6 minus 1. I'm just going to write it like that. I don't need to rewrite it or anything. I'm just going to plug it in. Now, if you do want to go ahead and put in the calculator the 6 minus 1, make sure you put it in parentheses. So we do that, and we get -1,944, which makes sense as these numbers are going positive and negative, and yet getting bigger at the same time. Alright, and then on this one, 3 times 5 to the 6 minus 1, which is going to be to the 5th power. Oops, sorry guys. So 3 times 5 to the 5th power, we're just going to go ahead and put 3 times 5 to the 5th. And we are going to end up with 9,375. Once again, we put the a sub 6. We don't just want to write out a random number. We want to show what it represents. And so if we look at what that represents, it represents that the 6th term of this sequence is 9,375. Alright, so on this one, it's wanting the same thing, it's just in a table format. It's no different. These are the number of terms, so the first term, the second term, the third term, and the 4th term. If you think about it, it's the same thing as if you had listed this out like I had previously with commas. It's no different. So don't feel like it's a big change from what we've been doing. So once again, we have our first term. Let's find our common ratio. So we can take any number. I'm going to take 108 and divide it by the number on its left, which is 324. So when I do that, I find that this one happens to also be 1/3. So on this one, my formula is going to be a sub n equals 2,916 times 1/3 to the n minus 1 power. And once again on this, because if you look at the instructions, this is for 13 through 20, it does want us to find a sub 6. So if we go ahead and find a sub 6, and that's just a number they chose, we could find anything. We go ahead and we type in 2,916 times 1/3 to the, and let's go ahead and put 5th power because it is n minus 1. So the 6th term in this sequence is 12. So once again, this is the first term. If you look at this, these are all multiplied times 4, so the common ratio is 4. So we have a sub n equals 11 times 4 to the n minus 1. In the 6th term, we're going to just type this into our calculator. We're going to do 11 times 4 And we don't put to the 6th, we put to the 5th because it was 6 minus 1. So the 6th term in this sequence is going to be 11,264. Alright. Alright, so in this, once again, same thing. We are writing out what the equation is to find this geometric sequence. They show it in point form. So think about these points. This number, this x component, is the number of terms. So the first term is 2. The second term is 6. The third term is 18. And the fourth term is 54. So right here, here's your a sub 1. And now we just have to find our common ratio, which you can tell is multiplying by 3. So we have a sub n equals 2 times 3 to the n minus 1 power. And once again, we want to go ahead all the way through number 20 and find a sub 6. So we do 2 times 3 to the 6 minus 1. And we would type that in our calculator. And I'm feeling pretty confident that you've seen me type it in enough at this point that you can probably type it in yourself. So I know that once I type it in, I'm going to get 486. So in this one, same thing. I'm getting my numbers right here. The second term's 6, third term's 12, 24, 48, and so on. So my terms are 2, 6, 12, 24, 48. So here's my first term right here. And then I know I'm multiplying by 2 every single time, so my ratio is 2. So I do a sub n equals 3 times 2 to the n minus 1. And to find the 6th power, once again, just go ahead, plug this into the calculator. And let me see here. If we do this, we should get 96. Okay, and same thing here. First term is 8. The second term, kind of got a hump for it here, is negative 4. The third term is 2. Make sure you write these in the right order, otherwise your life will be a struggle on this section. And then 0.5. So I think it is multiplying times a negative half because it's going positive and then negative every single time. And then the numbers are being halved. So it's being multiplied times a negative half, so that is your common ratio. And then your first term is 8. So our equation is going to be 8 times negative 1/2 to the n minus 1. Our 6th term is going to be, plug this in our calculator. And when we do this, we should get negative 1/4. And we want to always write that a sub 6. So what this represents is the 6th term is negative 1/4. Okay, so that's the end of the notes. Please, please, please take advantage of the notes on video. Back them up, rewatch them, pause them where you need to, and just make sure that you're filling these out so you come in ready for class tomorrow. Please come in with any questions you have. I'd be happy to help you.